Algebra 1 students, welcome to your video and your notes on solving by graphing for x-intercepts and solving by taking square roots. Okay, so here we go. All right, guys, so this is your 9.3 notes on solving quadratic equations. The big idea, there are several ways to solve quadratics. Today we are going to focus on two of them. All right, and the two we're going to focus on are graphing and square roots. So in this unit, when it tells you to solve using a specific method, you are going to have to use that method. There's going to be other ways that you can verify your answers, and a lot of you are going to revert to graphing just because I know what Algebra 1 students have done in the past. But you can use that as a fact check. Remember, I will allow you to use Desmos. So learn how to use Desmos to your advantage and learn how to use it as a fact check, and we're going to teach you that right now. So quadratic equations have solutions or roots, and quadratic equations have zeros or x-intercepts. And so these are going to happen at your x-intercepts, and I need to turn my pen on. And so we need to put arrows on these parabolas. And the solutions or the roots or the zeros or the x-intercepts are these bad boys right here, where you notice the graph of your parabola intersect the x-axis. And in this case, where you have two solutions, it's going to happen for this parabola. It's going to happen in those two locations where it intersects the x-axis. Now, there could be situations like these other two situations where you've got a parabola that opens downward and it intersects right here in one location right there at the vertex of the parabola, or maybe the parabola opens upward and it comes down here and has a minimum right there where the vertex touches the x-axis. When that occurs, you're only going to have one solution. There's another situation that could occur in algebra where you would have some parabola that has a vertex or a maximum that doesn't actually cross or go past the x-axis. And in that case, you're going to have no real solution. All right? And when you get to Algebra 2, you're going to learn about your imaginary friends, and that will be a great time. But we're not going to deal with that until we get to Algebra 2. So let's begin our notes today with these four problems, and we're going to solve by graphing. All right, so if you take a look at this page, one of the things that you're going to notice immediately is number 3 doesn't look like the other ones. Okay, all of these other four problems are equal to 0, and that's because you're really solving for y equals and then whatever function that you have. Okay, and these are obviously quadratic functions because we know how to name our polynomials now, but we are dealing with four problems here, and one of them looks different. That one that says x squared plus 7 equals 7. You can really only solve by graphing if your function is equal to 0. So just kind of take a side note and notice that in number 3, when we get to that problem, we're going to have to manipulate that problem so that it is actually equal to 0. Okay, so let's go ahead and jump over to Desmos now. Okay, you can see that I have entered my function into Desmos, and so what I'm going to do is I'm going to go ahead and zoom out and adjust my window that I'm looking at for this parabola, and you can tell that you have a vertex at -81, and you've got some x-intercepts right there at -9 and +9. Those are the things that we're going to include in our answer. So as we enter our answer in this worksheet, we're just going to say x is equal to -9 and x is equal to +9. Okay, and you can say it like this, or you can just simply say x is equal to plus or minus 9. That's one of those things that I bet a lot of you are going to take advantage of. Okay, let's go over to Desmos and take a look at number 2. Okay, so we're on Desmos. I've plugged in my function x squared plus 12. A lot of you get to this point and you show me your calculator and you say, Mr. Bear, it's not working. And it doesn't matter if you're on Desmos or if you're on your graphing calculator. If you're not looking at the right window, you're not going to see your parabola. All right, so adjust your window, and with Desmos, we can just pull this down. Okay, we can adjust just by pinching our fingers. And you'll notice that this is one of those situations where we have a vertex of our parabola. We have a minimum right there at 12, and the parabola opens upwards. So this parabola, this quadratic, has no real solutions. Okay, so I do expect you to put this word real into your answer because there are imaginary solutions that you're going to deal with when you get to Algebra 2. Okay, so I told you guys, I gave you a little bit of a indicator that we were going to manipulate number 3 so that it would be equal to 0. All right, and we can't work this, we can't solve this by graphing unless we've got a 0 over here. That 7 doesn't need to be there. So I'm going to just move that 7 over here with the subtraction property of equality. I've got a positive 7 here. I'm going to subtract 7 on both sides. When I do that, I end up with x squared is equal to 0. All right, so let's go and plug that into Desmos. Let's get that out of there. Let's do x squared. Okay, and you'll notice that with this parabola, we have a vertex right here at 0, 0. Well, that is the origin, okay? And this is what's considered a parent function for x squared. And so we have one real solution because the vertex of our parabola touches the x-axis, and it is at 0. Okay, so let's go ahead and plug that in on our notes. We've got x is equal to 0. Okay. And our last function is 5x squared minus 80. So let's plug that into Desmos. 5x squared minus 80. 5x squared minus 80. Okay, and then let's go ahead and adjust our window a little bit so that we can see the entire picture. We've got a parabola that, whoa, where did it go? We've got a parabola that touches the x-axis right there, and it touches the x-axis right there. It touches our y-axis there. It has a y-intercept of negative 80. That happens to be the vertex of our parabola. We've got x-intercepts at negative 4 and positive 4. Okay, so we can say x is equal to negative 4, or we can say x is equal to positive 4. We could also say it like that. Okay, so that is how you solve by graphing. Okay, and again, I told you in this unit that whatever technique it gives you, you have to use. You're not allowed to just pick whatever technique you would like. Okay, I have a lot of Algebra 1 students that when it says solve by taking square roots, they simply go and plug it into Desmos and then give me the answers. You need to show your work and demonstrate that you understand how to do the problem like this. Okay, so it says solve by taking square roots. So it says for any quadratic in the form of ax squared, and that could be a plus or minus c, equals 0, solve by isolating x squared and then take the square root of each side of the equation. Remember, if x squared is equal to c, then x is equal to plus or minus the square root of c, okay? And so if you take the square root on both sides of the equation, you have to say this plus or minus right here. If you don't do that, that's an issue, and you are going to lose half of your points, I guarantee it. Okay, so here's what you're going to do. We've got a squared is equal to 225. again, I'm going to isolate the variable by taking the square root on both sides. Anytime I do that, I've got plus or minus the square root of 225 over there. This square root takes care of the a squared. Now I've only got one a sitting there. All right, and we know that 225 is, or the square root of 225 is 15. So a is equal to plus or minus 15. Now what's very interesting about this is if you were to plug your function a squared minus 225 into Desmos, you would actually get a parabola that has x-intercepts at plus and minus 15. So that is a way that you can fact check all of your answers in this unit. All right. So for number 6, it looks a little bit different. We've got a little bit more going on. I need to isolate, it says in our notes, I need to isolate this b, or this w squared. So I'm going to use the addition property of equality, add 8 to both sides. I'll have 3w squared is equal to, well, that's going to end up being 0. I can use the division property of equality to get that 3 out of there. So I'll have w squared is equal to 0 divided by 3 is still 0. I can take the square root on both sides, and I would end up with w is equal to plus or minus the square root of 0. The square root of 0 is just 0. There's no plus or minus. So in this particular case, w is equal to 0. That would be one of those situations where you have a vertex of your parabola touching the x-axis right there at x equals. Okay, so for number 7, I'm going to use the division property of equality to divide both sides by 4. When I do that, I end up with x squared is equal to 1. I can take the square root on both sides of my equation, and I would have x is equal to plus or minus the square root of 1. And 1 times 1 is equal to 1, so we've got x is equal to plus or minus 1. All right, on number 8, some of you might start to look at that one and notice, hey, that one's going to do something I'm not going to like. Don't freak out when you see fractions, okay? I can divide both sides by 16 using the division property of equality. I've got v squared is equal to 9/16. Okay? I'm going to use the same process. I'm going to use the square root on both sides of my equation. So I've got v, it's not squared anymore, is equal to plus or minus the square root of 9/16. And if I wanted to, I could rewrite this one as plus or minus the square root of 9 over the square root of 16. I think that'll help a lot of you out. Okay? And after I do that, I would say v is equal to plus or minus 3/4, because the square root of 9 is 3, the square root of 16 is 4. And so don't freak out when you see fractions, okay? A lot of you quit on me whenever it's time to do some fractions. All right, number 9. Again, I'm using the division property of equality. I divide both sides by whatever's sitting in front of x squared. That helps me isolate x squared, or get x squared all by itself. Okay? Now I've got -4 chilling over there. Okay? 16 divided by 4 is 4. A positive divided by a negative is a negative. And some of you might start to realize, oh, something's going to happen here. If I take the square root on both sides, I would get x is equal to plus or minus the square root of -4. Well, when you get to Algebra 1, you don't know how to do, or we won't teach you how to deal with a negative inside of a square root. And you will learn how to do that when you get to Algebra 2. That's when you start dealing with your imaginary friends. Okay? And some of you are like, Mr. Barry, you are crazy. And I'll just tell you, thank you. All right, so x is going to be, well, I'm not even going to say that. I'm going to just say no real solutions. So I just want to reiterate a very important point that I made earlier in this video. If it tells you to use a specific technique, you must use that technique in this unit. If it tells you to solve by taking square roots, if it tells you to solve by graphing, you need to do that. Solve by graphing, you actually need to sketch a graph. Later in the unit, it's going to tell you to solve by factoring, and it's going to tell you to solve by using the quadratic formula. And you have to use Folks, that concludes our video. I will see you in class.